Hi all, my name is Satrio Caksono, and I'm here to continue our discussion on bending, where I want to explain in detail about moment of inertia. In the previous video, I already explained the relation between the normal stress due to bending and the moment bending, which happening at a beam. Okay, the relation is as you can see here. The stress is equal to minus moment multiplied by the distance from the natural axis divided by I, where I is the moment of inertia. And in the previous video as well, I already explained that the moment inertia is equal to integral of the y square dA. In this particular slide, I will discuss about the moment of inertia for two most common shapes. Okay, the first one is rectangular like this. By using this equation, we can find out that the moment inertia against the x-axis here will be b h to the power of 3 divided by 12. The other shape that I want to discuss about will be the circular shape. Using this particular equation as well, we can find out that the moment inertia against x-axis will be pd to the power of 4 divided by 64. You should remember that all of this moment of inertia is against the x-axis, which is through the centroid. In some cases, we need to find the moment of inertia against other axis which is not through the centroid, like in this picture. As you can see, the red axis is not through the centroid. And if we want to find the moment of inertia of this particular thing against the red axis, we can use the parallel axis theorem, which stated that the moment of inertia against another axis is equal to the moment of inertia of the things against the axis which is through the centroid, okay, plus a multiplied by dy square, where a here is the area of this thing and dy is the distance between both axes. In order to ensure that you all understand about the topic that we discussed today, let's try to solve this example together. For this kind of case, the moment of inertia is supposed to be the summation of all moment of inertia, which in this case are two webs, the upper web and the bottom web, and the flange. The flange do not need to use the parallel axis theorem because the axis here is already going through the centroid of the flange. So we can directly calculate it, the moment of inertia of the flange using this calculation. The web, on the other hand, we need to use the parallel axis theorem because the centroid of the web, the upper web, is around here and the centroid of the whole things is around here. So we have to use the parallel axis theorem. As you can see here, this is the moment of inertia of the web, one web, against the middle axis of the web. Then we have to add it with the area of the web multiplied by the distance between the axis of the web with the axis of the holdings. In this case, the distance is 150 millimeters plus 20 millimeters divided by 2, which is 160 millimeters. That's why then we can calculate the moment of inertia of the holdings using this equation. And the results is this one. I think that's all. Thank you very much.